Okay, part 2 of this is where we're actually going to do the solving. We're going to use the information that we've gone over. So first things first is I want to practice this whole solving thing, right? Done it before, lots of times. This is a quadratic. Make sure it's set equal to 0. Then we're going to try and factor. It's a trinomial. There was no GCF. It's a trinomial, 3 terms, leading coefficient of 1, so it's a nice easy one. Two numbers that multiply to negative 12 add to negative 4. That is negative 6 and positive 2. So my factors are x minus 6 and x plus 2. Now that is set equal to 0. Each one of those gets a possibility of being equal to 0. So x equals 6, x equals negative 2. Now doing that with a quadratic, we have all the methods we need, right? We have the 4 methods you can use, factoring if possible, square root method if possible, completing a square, and that handy dandy quadratic formula. But when it comes to ones like this over here, that one's not easy to factor, right? I can't think of, in fact, we don't even know a way to do it with x cubed and x squared and no x at all. So in this case, we have to come up with a different method of solving this equation. So two theorems that we've learned so far are called the factor theorem and the remainder theorem. We're going to actually join those two together to find a way of factoring any polynomial. So factor theorem says this guy has a factor of x minus k if and only if f of k equals 0. And then down here with the remainder theorem, it says if you divide by x minus k, then the r is the same thing as f of k. So I'm going to join these two together. Now what it says is if you divide by x minus k and the remainder equals 0, then x minus k is a factor. So here's basically what I did. I took this idea with this idea and joined them together to make that. So the easiest way to do this is within synthetic division. This is a simple quadratic. We could factor it, but I want to use this to help practice. X minus 3, I want to know, is it a factor? So I'm going to divide it out of this quadratic. And I'm going to use synthetic division. 3 is on my outside. Remember, that's A. Inside are going to go my coefficients, checking to make sure no terms are missing. Process says bring down the first term, multiply diagonally, add down. Multiply diagonally, add down. This is not 0. So that means x minus 3 is not a factor. Okay, let's try this next one. This time we've got x equals 1, so my a is going to be 1. It's the guy on the outside. Okay, same coefficients on the inside. Follow the steps. Woohoo! Remainder is 0. Woohoo! That means x minus 1 is a factor. Okay, So back here when we were solving and we found all the factors, to finish solving, we set each one equal to 0 and finish solving to figure out what x was. So if we can take any polynomial, including ones like this, if we can factor it out, then we can easily solve it. So we're going to use that and this stuff to find all rational zeros of a polynomial function. So first we're going to start with that property we learned in the last one where we take our p's and q's, right? P is going to be the factors of 20. Q are the factors of 1. This is from polynomial finding zeros part 1. So the factors of 20, I just go through the list. I say yes, 1 always divides into them. 2 divides into it, yes. 3, no. 4, yes. 5, yes. 6, 7, 8, 9, 10, yes. And then the last one is 20. So I just work my way through the list. All right, so that means, oh, also don't forget that the pluses or minuses are options as well. Plus or minus. This guy's going to be plus or minus 1. So P over Q equals 1 divided by 1, 2 divided by 1, and so on. It's just going to be those P values. Okay. Now, in the last part, we also saw how to find the zeros by looking at a graph. So we're going to start with looking at the graph. Okay, X. Wrong keyboard. Sorry, my throat's got a frog. Ribbit. Ribbit. Talking to myself now. 8x squared plus 11x plus 20. Okay, so here's the graph that we're looking at. Now I know with this graph, you can look at it. Let me change my window so it's counting by the right numbers. That's a nice normal graph. Now I know on here you can actually find the zeros. Looks like there's 3 of them, and it's at -1, 4, and 5. But we're not practicing just looking at the graph and identifying them. We're finding this new method because you're not always going to be able to find those just from the graph. Okay, so we know that this 3 tells us we're supposed to have 3 zeros, 3 solutions. F of x equals 0 is what we're looking for. Oops, sorry, it says P of x. And we know those numbers. I'm just going to pick one of them and start with that, though. So I know that -1 is an answer. So we go -1 and put in our coefficients. Okay, now wait, why did we do -1 and not +1? Well, what we have is already, we know that x equals -1. That's the step before this. So x plus 1 equals 0. Sorry, no parentheses. Which means x minus 1 was one of the factors. Okay, let's prove. So like I was saying, you can look at the graph and find the numbers, but I want you to actually prove to me that it is a 0. And that's done with synthetic division. What in the world just happened there? All kinds of dots. Okay, step says bring down the first term, multiply, and add down. Multiply, add down, multiply, add down. 0. Woohoo! I have proved that that is a 0. Okay, so here's how this works. Use synthetic to find the one. Now let's say we didn't know it was 4 and 5. We didn't know what our other values were. So at this step, we're going to put the variables back in. Started at x cubed, which means I go to x squared, and then x plus 20. Now, that is the leftover piece. So to find the rest of the solutions, you would just solve that equation. This factors into x minus 4, x minus 5. That means x minus 4 equals 0, or x minus 5 equals 0. So x equals 4, or x equals 5. So when you are solving these, and you have a number from the graph, you don't need to change signs, right? We were doing opposites before. Okay, so our steps were pick one of the zeros. If you can, get it from the graph. We picked -1. Then I used synthetic division to quote unquote prove that it was a 0, and I proved it by getting a remainder of 0. And then to finish solving it, to find the rest of the factors, I took the answers, put my variables back in, made the equation as quadratic, set it equal to 0, solve and found my other zeros, which are 4 and 5. So my solutions are -1, 4, and 5. So use the graph to identify synthetic division. You're looking at the ones that have a remainder of 0. And then you keep testing values until the remaining equation is quadratic. And then use whatever method you know to finish solving. All right, let's look at another one. Oh, yes, here. You may use the graph to identify some zeros, but you have to prove it. So I just want to see the synthetic division that proves that that's actually a 0. It's nice and easy. I don't want you to just be able to identify them from the graph. I want you to be able to do it with any polynomial.